This is our Sun. A fairly ordinary star by the standards of the Milky Way, yet perfectly suited for life on Earth. Measuring merely 1.4 million kilometres across, it has provided light and warmth to our planet for around 4.6 billion years. Every second, nuclear fusion in its core releases an immense amount of energy, maintaining Earth's climate and powering almost every ecosystem. Compared with many of the stars we'll encounter today, our Sun is surprisingly average. And that average is precisely what makes life possible. Proxima Centauri, our nearest stellar neighbour, located just over 4 light-years away. Yet this red dwarf is a cosmic featherweight, emitting a mere 0.17% of our Sun's energy. Placed in our orbit, familiar daylight utterly vanishes. The midday sky plunges into a permanent frozen night, stripping the atmosphere and baring the Milky Way to the naked eye. As temperatures plummet toward absolute zero, oceans flash freeze, ecosystems collapse, and Earth is left a silent, icy corpse, adrift under a dying red ember. Barnard's star is one of the oldest stars in our region of the Milky Way, and slightly brighter than Proxima Centauri. Even so, it emits only a tiny fraction of the Sun's energy. Earth would remain trapped beneath a dim, orange-red sky as global temperatures continued to fall. The oceans would eventually freeze beneath kilometres of ice, and over time, much of the atmosphere would condense onto the surface. It would be a silent, frozen planet, with virtually no chance for life to continue naturally. Alpha Centauri A is the closest true Sun-like star to our solar system. Although slightly larger, hotter, and around 50% more luminous than our Sun, it remains remarkably similar. From Earth, the sky would look almost familiar, with only a brighter, whiter daylight hinting that something had changed. The additional energy would make our planet significantly warmer, forcing humanity to adapt with new technologies, different agriculture, and stronger protection from ultraviolet radiation. Unlike every star we've seen so far, life on Earth could still continue. Sirius A is the brightest star visible in Earth's night sky. Although it's only about twice the Sun's diameter, it radiates roughly 25 times more energy. If Sirius A replaced our Sun, the familiar golden daylight would disappear, replaced by an intense blue-white glow. Earth's surface would absorb far more energy than it could release back into space. Temperatures would rise dramatically, oceans would begin to evaporate, and water vapor would trap even more heat in the atmosphere. Within a relatively short time, our planet would become far too hot for complex life to survive. Vega is one of the best-studied stars in our galactic neighborhood, and thousands of years from now, it will become Earth's North Star once again. It shines around 40 times more brightly than our Sun. From Earth, the sky would be dominated by a brilliant white-blue star, flooding the atmosphere with an almost icy light. But beneath that beautiful sky, the planet would be experiencing an environmental catastrophe. The oceans would boil into a dense blanket of superheated steam. Surface temperatures would soar far beyond the boiling point of water, and every ecosystem on Earth would collapse. Achernar is one of the fastest spinning stars ever discovered. It rotates so rapidly that it has become noticeably flattened, bulging around its equator instead of remaining perfectly spherical. Despite its unusual shape, the real danger comes from its extraordinary energy output. At roughly 3,000 times the Sun's luminosity, Earth wouldn't simply become hotter, it would become unrecognizable. The atmosphere would be stripped apart, the oceans would completely disappear, and the surface itself would begin to melt beneath an overwhelming flood of radiation. 'Th- 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 ' Pollux is an orange giant that has reached a later stage of stellar evolution. Although its surface is cooler than the Sun's, its enormous size allows it to radiate more than 40 times as much energy. Earth would be illuminated by a deep, golden-orange sky, unlike anything seen today. The warmth of sunlight would be replaced by relentless heat. Oceans would steadily evaporate, continents would dry into vast deserts, and temperatures would continue rising until the planet could no longer support life. Arcturus is one of the oldest bright stars visible from Earth. Over billions of years, it has expanded into a magnificent red giant more than 25 times wider than the Sun. From Earth's orbit, this enormous star would dominate the horizon with a deep orange glow. Any remaining oceans would vanish completely, leaving behind a scorched landscape of cracked rock. Eventually, even Earth's crust would begin to soften under the relentless energy pouring down from above. Canopus is the second brightest star visible in Earth's night sky, and one of the most luminous stars in our local region of the Milky Way. With a diameter approaching 100 million kilometres, it would appear absolutely enormous from Earth's orbit, stretching across a large portion of the sky. The amount of energy reaching our planet would be overwhelming. Long before the star filled the horizon, Earth's oceans would have completely disappeared. The atmosphere would become superheated, and the rocky surface would begin melting into vast rivers of magma. Our planet would no longer resemble the blue world we know today. Polaris A, better known as the North Star, has guided travelers across the Northern Hemisphere for centuries. Although its surface temperature is similar to our Sun's, it's vastly larger and over 1,000 times more luminous. The familiar yellow daylight would remain, but the star itself would dominate the sky, appearing far larger than the Sun ever has. The intense radiation would rapidly strip away Earth's oceans and leave behind a barren landscape of scorched rock and molten terrain. Rigel is one of the most powerful stars visible to the naked eye, and the brilliant blue beacon marking Orion's left foot. If it replaced the Sun, the scale would become almost impossible to comprehend. Rigel is so enormous that its visible surface would extend across a significant portion of the sky, making it feel less like a distant star and more like a glowing wall of blue-white plasma. The radiation would be so intense that Earth's crust would rapidly vaporize, leaving no trace of the planet's former oceans, continents, or atmosphere. R136A1 is one of the most massive and luminous stars ever discovered. It shines with several million times the Sun's luminosity, making it one of the brightest known stars in the universe. From Earth, the sky would be filled with an intensely bright blue-white star, flooding the atmosphere with energy beyond anything our planet has ever experienced. The surface wouldn't simply melt, it would vaporize. Rock, metal, and every remaining part of Earth would be reduced to superheated plasma in the overwhelming torrent of radiation. WR102 belongs to one of the rarest classes of stars in the universe, the Wolf-Rayet stars. With a surface temperature exceeding 200,000 degrees Celsius, it's among the hottest stars ever observed. From Earth, it would appear as a brilliant blue-white point surrounded by glowing clouds of ionized gas, creating an extraordinary purple sky. Yet beneath that spectacular view lies one of the deadliest environments imaginable. Its intense ultraviolet radiation would strip away Earth's protective ozone layer almost instantly, exposing the surface to lethal radiation and sterilizing the planet within moments. Sirius B is the dense remnant left behind after a sun-like star exhausts its fuel. Although it's roughly the size of Earth, it contains almost the same mass as our Sun, making it one of the densest objects in the universe. Its surface is incredibly hot, but because it's so small, it emits only a tiny fraction of the Sun's total energy. From Earth, it would appear as a brilliant blue-white point of light, suspended in an almost completely dark sky. With so little heat reaching our planet, temperatures would continue falling until Earth became a frozen world, locked in permanent night. RxJ 1856.5-3754 is a neutron star, formed when a massive star collapses under its own gravity after a supernova. Despite containing more mass than the Sun, it's only around 28 kilometres across. Its surface temperature reaches hundreds of thousands of degrees, yet its tiny size means very little heat would reach Earth. The result would be a hauntingly beautiful sky, with a tiny electric blue point shining above a planet frozen in perpetual darkness. Beneath that beautiful view, however, Earth would slowly become an airless, lifeless ice world. PSRB 1509-58 is a pulsar, a rapidly rotating neutron star that sweeps powerful beams of radiation across space like a cosmic lighthouse. It spins more than 6 times every second, while releasing intense X-rays and gamma rays into its surroundings. From Earth, the sky would be illuminated by an eerie, rapidly pulsing blue light, accompanied by spectacular aurora-like displays high in the atmosphere. But those beautiful lights would signal something far more dangerous. The relentless radiation would strip away Earth's atmosphere and expose the surface to lethal levels of energy long before life had any chance to adapt. SGR 1806-20 is a magnetar, an exceptionally rare type of neutron star with the strongest magnetic field ever observed. Its magnetic field is estimated to be around 100 trillion times stronger than Earth's. If it replaced the Sun, strange electrical phenomena would dominate the sky, with brilliant auroras and violent atmospheric discharges stretching across the horizon. Yet those spectacular displays would only be the beginning. Its intense magnetic field and bursts of high-energy radiation would rapidly destroy Earth's atmosphere and expose every living organism to conditions no life could survive. We'll end with one of the most misunderstood objects in the universe. A black hole with exactly the same mass as our Sun would not pull Earth into it. At our current distance, its gravitational pull would be identical, meaning Earth would continue orbiting exactly as it does today. The difference is that a black hole produces virtually no light of its own. The Sun would simply disappear, leaving behind only a perfectly black sphere that subtly bends the light of distant stars around it. Without sunlight, Earth would fall into permanent night. The Milky Way would shine brighter than ever before, but the planet beneath it would slowly freeze into a silent, lifeless world.